Lunar gravity is just 1/6 of Earth's. One small step sends you soaring into the vacuum.
But today, we're not talking about 6 times weaker. We're talking about 10. Weaker than the moon. Weaker than anywhere humans have ever tried to survive long-term. And that one detail changes almost everything you're about to see. So let's start with the very first second gravity changes. Hour 1. The world feels like a playground. Your bones and muscles evolved under constant gravity. Every step you've ever taken has quietly told your skeleton, stay strong, you need this. Take that pressure away, and your body starts believing it doesn't need to be strong anymore. We already know what happens next because we've seen it before. Astronauts living in low gravity for months lose bone density and muscle mass at an alarming rate. Now imagine that happening to every single person on Earth at the same time, permanently. Your heart is affected too. It's used to pumping blood against gravity's pull. Suddenly, blood shifts upward too easily. Astronauts call this puffy face syndrome. On Earth, at this scale, it would mean millions of people dealing with dizziness, fluid imbalances, and blurred vision within days. So here's the price of jumping over a house. Your own body slowly starts falling apart from the inside. Here's the twist most gravity videos never get to. Gravity isn't just what holds you to the ground. It's what holds our entire atmosphere close to the planet. Air molecules are constantly moving, and gravity is the invisible leash keeping them from drifting into space. Weaken that leash enough, and the atmosphere doesn't just get a little thinner, it starts leaking away. We've actually watched this happen before, just not on Earth. Mars, with gravity far weaker than ours, lost most of its atmosphere over hundreds of millions of years. Now, at 10 times weaker gravity, Earth's atmosphere wouldn't take hundreds of millions of years to thin out. It would happen dramatically faster, faster than any civilization could realistically adapt to. The floating, jumping superhero fantasy from the start of this video is quietly turning into a countdown. And the sky isn't the only thing losing its rules. The ocean is too. Oceans, tides, and weather unravel. Atmospheric pressure depends heavily on gravity. Change gravity, and weather patterns change with it. Storm systems could grow larger, slower, and far less predictable. Meanwhile, tides, driven by the gravitational relationship between Earth and the Moon, start behaving strangely as Earth's own gravitational grip shifts. Coastlines that have followed the same tidal rhythm for thousands of years suddenly stop making sense. Even the sky and the sea no longer follow the patterns humanity has trusted for its entire existence. At this point, you might be wondering something bigger. If Earth's gravity gets weaker, does that mean Earth itself starts drifting away from the Sun? Could Earth even stay in orbit? Here's an important clarification, because this is where a lot of people get it wrong. An object's orbit depends on its mass, not the strength of gravity felt on its surface. If Earth's surface gravity changed, but Earth's actual mass stayed the same, our planet's orbit around the Sun would remain completely intact. The Moon would still circle us. We would still circle the Sun. The chaos in this scenario isn't cosmic, it's local. It's happening to us on the surface, not to the planet's place in space.